Hotspot starts executing a Java program, the bytecode. It does not optimize anything. Instead, it counts the number of times each method has been executed. And when a method has been executed a sufficient number of times, the whole method is optimized. They distinguish between client and server JVMs, since servers are such programs are expected to run for a longer time, so they can use more advanced optimizations or more sophisticated, time-consuming optimizations. It can also be the case that a loop within a method is run a sufficient number of times, iterations I mean, then that loop is also optimized. The JVM makes guesses about the input, and therefore it can make speculative optimizations. They are validated by runtime checks, and if it's the case that it did an optimization which was based on false assumptions, then that method is de-optimized. But it can later be optimized again if it's run sufficiently frequently. And de-optimization can also be done when a new class is loaded. So, the client optimizations, what happens? First, the control flow graph is constructed by, well, inspecting the bytecode. And then the purpose is to translate the stack-based bytecode to a register-based intermediate representation. And this is done by simulating the execution of the operations on the stack. This replaces the Java bytecode with SSA form. And this representation is called the high-level intermediate representation. Okay, so what does the client JVM do? It does, for instance, constant folding, value numbering, and inlining. But many optimizations that we have studied in this course are not done. Okay, and the low-level intermediate representation, which is not on SSA form, it's essentially symbolic assembler code, as in Bell Labs Inferno virtual machine. And it has an unlimited number of machine registers, I mean symbolic machine registers, and then they are use register allocation to map them to real registers. The server hotspot JVM, I mean the execution on servers, it does the same optimization, but also constant propagation, dead code elimination, instruction scheduling, graph coloring, loop unrolling, and loop invariant code motion. That's one part of PRE, to move code out of loops. Okay, so this is quite similar to normal compilers. There is a disadvantage with just-in-time compilation, and it is that the compilation and optimization is done during the execution. Well, that is an advantage also, since more dynamic, more information is available about input, for instance. But it still takes time, and therefore limits the optimizations which can be done, so that they don't take hours, for instance, which is not very frequently used for ahead of time compilation, but it can be useful to use advanced optimizations for programs which are run a lot of time. Okay, so what one part of Oracle research organization have done is to do ahead of time compilation of Java bytecode into normal executable files. And this is done using the Graal virtual machine. And this is a very fascinating modern technology that can reduce the startup time by up to 50 times and create smaller binaries by up to 5 times. The output from the Graal virtual machine are completely normal executable files. So no Hotspot compiler is needed to to put in an embedded system, for instance. Okay, and their approach also makes it possible to write programs which use multiple different languages using a special framework called Polyglot. And it includes C, Python, Java, and Ruby, and other languages. So, in my view, this will be something very interesting.